are supposed to have 3 zeros, and is that what we see? Absolutely. Look at that graph, and it's got -2, -1, and 2. Okay, this one over here says we're supposed to have 4 zeros. And what I can see from the excuse me, x-axis is a 0 here and a 0 here. X-intercepts are zeros, right? So I see it at -2 and 2. Now, it's supposed to have 4, but it only looks like it crosses the x-axis once at each of those points. Or I'm sorry, it only makes an intercept at these 2 points. My words. Blah, blah, blah. My words. Okay, so here's the difference between these two graphs. At this x-intercept right here, and this one, the graph is actually crossing through the x-axis, crossing over the x-axis. But what's happening over here? These guys are just touching it. They're not crossing. They touch it and then go back in the same direction they came from. We call this a bounce. These guys are bouncing. So what happens is if an intercept is a bounce, that means those intercepts, those values happen more than once. So considering the fact that they bounce, my zeros are -2, -2, 2, and 2. What happened was these numbers came up twice when we figured out what those zeros were doing it by hand. That's called multiplicity, by the way. Repeated solutions or zeros, when a factor, x minus k, happens more than once, and we'll talk more about that as we go, it's called multiplicity. As far as a graph goes, if it crosses the x-axis, then that value has odd multiplicity, usually 1. It could be 3, it could be 5, but usually it's 1. If it bounces off the x-axis, then it's got some kind of even multiplicity. So this means it could happen 1, 3, 5, so on. Even means it can happen an even number of times. So looking at this graph over here, this 3 right here, do you think that was an earthquake? Says we're supposed to have 3 zeros. So looking at my x-axis, I've got an intercept here and an intercept here. It's only 2 though, so I'm going to assume that there's some kind of multiplicity here because that's the bounce. All right, so we know for sure that 0 is a 0, and we know for sure that 4 is a 0. Now, if we were supposed to get 3, that means there's only a possibility of having one more 4. There couldn't be 4 4s because that would give me a total of 5 zeros. So I'm looking for a total of 3. This was one of them. I had to get 2 more, and that came from repeating that 4. Another way you can write this is listing the zeros as 0, 4, and then writing m equals 2 out to the side. And that says, hey, this had multiplicity 2. It happened more than once. Uh-oh. Close enough. Okay, let's look at this one. How many zeros? Degree is 4, so we're looking for 4 zeros. Looks like we have one here and one here, and they both bounce. So we know we're going to have multiplicity. All I really need is those 2 numbers. Now, it looks like 1.5 and -1.5, but looks like isn't going to be completely accurate. So let's list all the possibilities that we could have and see if those values are in there. If they are, then I'm going to trust that that's the numbers that we need. So starting with p's, those are the factors of 81. Does 1 divide into it? Yes. 2, no. 3, yes. 4, 5, 6, 7, no. 8, 9, I think 9. 18, no. 27, going through my head, kind of doing all the combinations. And then 81 as well. And then all the q's are the factors of 16, which are 1, 2, 4, 8, going through the numbers in my head, sorry, and 16. Is that really it? 1, 2, 3, 4, 5. That's it. Okay, all possible values, all p's and q's, the numbers that could be my possible rational zeros, right? Possible rational zeros are plus or minus. Now this is going to be a long list because we have a lot to list there. If you do it with this in the denominator first, right, the q of 1, then you just get the original list of numbers. 139, 27, 81. Picture each one of those being divided by this one guy right here, right? Over 1, over 1. Blah, 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 but we don't need to put that on there. Okay, that's just the first 5. Technically the first 10, because they should all have a plus or minus out in front of them. Who changed my color? Oh, it was me. Now you're going to repeat the same numbers, but this time you would put a 2 on the bottom. So we're going to go with plus or minus 1 over 2, comma, plus or minus 3 over 2, plus or minus 9 over 2, 27 over 2, and 81 over 2. And then you would reduce any fractions if you could. Now that's not even the full list of it. I'm going to stop right there though, because obviously this is going to be time consuming. And I'm going to look and say, oh, look right there. 3/2 and -3/2 are possibilities. So I'm going to stick with my original and say, yes, those are 3/2 and -3/2. So our zeros are -3/2, multiplicity 2, and +3/2, multiplicity of 2. And that would be all 4 zeros that I was looking for. Okay, let's try this one. Use the graph of the function to find all zeros. How many are we looking for? Degrees 4, so we've got to find 4 of those guys. Okay, right away I look here at this one and I say, okay, -3 is on there, so -3 is a 0, and it bounces, so it's got multiplicity. Dang it, I always forget to lock these guys. Sorry, just a sec, hold on. Man, now I gotta erase some stuff. Oh, it's okay. Okay, 4 degree means 4 zeros. So it bounces, which means it has multiplicity. Now, could it have multiplicity of 4? Could there be a -3 as a 0 4 times? Sure, it could. It would be similar to having, whoops, 4 as your, that would be your equation. So maybe it was -3 with multiplicity 4. It could also have -3 with multiplicity of 2. Now, if -3 has a multiplicity of 2, then what would the other 2 solutions be? Well, our list right there, our possibilities, our P's and Q's. P are the factors of 9. Q are the factors of 1. So my P over Q's are plus or minus 1 over 1, technically, plus or minus 3 over 1, plus or minus 9. Now, it's obviously not positive or negative 1, not 9 either, and 3, only the negative 3 shows up. If it was on the other side, I'd show you that. So this was a list of all possible rational zeros. Rational zeros, so maybe there's an irrational. Irrational still has points on the graph, so there's no more irrational. So I'm trying to think, what would that mean? If I set this equation equal to 0 and I tried to solve that, there are rational numbers I could get for my solution, irrational numbers I could get for my solutions, like square root of 2 or square root of 3 or something like that. And then there's one other type of solution I can get, and that's imaginary. So if this had been the case right here, where multiplicity on the negative 3 was only 2, the others would be imaginary solutions. These imaginary guys, they don't show up on x-axis. They are not x-intercepts. They're imaginary. They can't be, right? So there cannot be x-intercepts to show you the imaginary solutions. You know how good I am at talking and writing at the same time. So two possibilities there, and it's actually this one right here. This equation does not multiply out to what that one would. So the thing from this one is I want you to see that the x-intercepts are not always on the graph. They're not always going to be in this list of possible rational zeros. There are different possibilities, and that's when you include the negative values. I'm sorry, the imaginary values. Bleh.